नमस्कार दोस्तों, वेलकम टू गेट वाला। मैं हूं सतीश कुमार, फैकल्टी ऑफ मेजरमेंट्स। बार्क एग्जाम का मेजरमेंट्स का फुल सीरीज को मैं स्टार्ट कर रहा हूं, मेजरमेंट्स का फुल सब्जेक्ट। सो आज हम डिस्कस करेंगे मेजरमेंट्स में क्या क्या डिस्कस करने वाला है, मेजरमेंट्स क्या टॉपिक्स एक्सपेक्ट कर सकते हैं। सो बेसिकली द क्वेश्चंस फ्रॉम द मेजरमेंट्स वी कैन एक्सपेक्ट फ्रॉम एरर एनालिसिस, error analysis. Okay, next measuring instruments like PMMC, okay, moving iron, okay, and dynamometer, okay. Next energy meter. Next electronic measurements. So these are the major topics. okay, so ये हमारा मेजर टॉपिक्स है, आज हम डिस्कस करेंगे। जितने लोग लाइव में हैं मुझे एक बार कंफर्मेशन कर दीजिए बेटा। ओके, सो दीज आर द टॉपिक्स। सो फटाफट हम स्टार्ट करेंगे क्वेश्चन सीरीज वन बाय वन। सो दिस आर फर्स्ट क्वेश्चन, ट्राई टू आंसर दिस क्वेश्चन। गुड इवनिंग सर, गुड इवनिंग। या पेपर हुआ नहीं है सर, पीडब्ल्यू बैच लिया पर पूरा मेजरमेंट नहीं कर पाया। क्या क्या नहीं कर पाया? ओके ओके, 12 members are watching. ओके ओके दिव्यांशु, कोर्स पूरा सर। ओके ओके ओके, कैसा लगा पेपर आज? आज तो पेपर है ना आपका इंस्ट्रूमेंटेशन। आपकी विच ब्रांच ग्रुप यू आर दिव्यांश? ओके, so let us solve these questions फटाफट। ट्रिपल का कल है। ओके ओके ओके, ट्रिपल, so no problem, so you can follow these questions. okay, you can follow these questions my dear. Yeah, two resistors with nominal resistances R1 R2 have additive uncertainties delta R1 delta R2 respectively. When these resistors are connected in parallel, the standard deviation of the error in the equivalent resistance R is dash. So generally how to, I told you uncertainty. So as per the uncertainty concept, uncertainty is a methodology to measure the error. okay, uncertainty is a methodology to measure the error. okay, so for example W is a function of x and y, and the most important concept here is this x and y must be independent to each other. Independent to each other. okay, independent to each other, they are not dependent on each. okay, they are independent to each other. So uncertainty in x, suppose uncertainty in x, this is the uncertainty in x, this is uncertainty in x, and Wy is the uncertainty in y, and Wz, sorry Z, let us take this Z, okay, uncertainty in Z. So uncertainty in Z is given by, okay, dou Z by dou x whole square, uncertainty in x whole square plus dou Z by dou y whole square, uncertainty in y whole square. So this is the square root. Okay, so in the same way, in this problem what is given, delta R1 and delta R2 are uncertainties. So he has very clearly mentioned delta R1 and delta R2 are uncertainties. Then what happens? R is a parallel combination. R is a parallel combination of R1 and R2. So uncertainty in delta R, that can be given as square root of dou R by dou R1 whole square, uncertainty in R1, that is delta R1 square, plus dou R by dou R2 whole square, uncertainty in R2 whole square. So that is a formula, my dear. Okay, so jaldi se jaldi answer kar do beta. Yes, very good, very good, nice to see you. Chalo. So what is the answer for this question now? The answer for the question is dou R by dou R1. So this is going to be the right answer for this question. Okay. So let us go for the next question. Answer this question here. Try to answer this question. So what is asking? Match the following is given. So this is a match the following. Instrument type P, permanent magnet moving coil. Q, moving iron connected through current transformer. R, rectifier. S, electrodynamometer. DC only, AC only, AC and DC. Try to answer this question. I'm waiting for a response. आठ मार्क्स वी कैन एक्सपेक्ट. बार्क में अच्छा वेटेज रहेगा मेजरमेंट्स को, बार्क में अच्छा वेटेज रहेगा मेजरमेंट्स को भैया. You will have a good weightage in, yeah. What is the answer here? See, permanent magnet moving coil, first of all it will go for DC only. So this is will go for DC only. Okay, pakka. Then moving iron, actually it is suitable for both AC and DC, but he is mentioned that moving iron connected through current transformer. So current transfer means it is AC only. So definitely Q goes to AC only. Okay, Q goes. Why? Because if current transformer is not there, it is suitable for both AC and DC, but current transfer is mentioned over there. So definitely when current transfer is mentioned, current transfer is used for scaling purpose, right? High voltage to low voltage. So definitely Q goes to this AC only. Rectifier and electrodynamometer, we know that AC to DC. Rectifier also we can suitable for AC to DC. Okay, so P goes to 1, Q goes to 2. Okay, R and S both goes to 3. So option B is the right answer. Even rectifier also we can choose it. Okay, wow. So rectifier also we can choose it, my dear. Yes, perfect. Yes, बढ़िया. So let us go for the next question. Yeah, try to answer this question, my dear. Try to answer this question. Answer this question. Suppose the resistors R1 and R2 are connected in parallel to give an equivalent resistor R. If resistors R1 and R2 have tolerance of 1% each, and the R1 is equal to 300 ohms, R2 is equal to 200 ohms, will have a tolerance of dash. Try to answer. मैं 1 मिनट टाइम दे रहा हूँ आपको, 1 मिनट का टाइम दे रहा हूँ, जल्दी से जल्दी बताओ 1 मिनट के अंदर. So Pradhan, you are telling option B is the right answer. Let us see how to solve this question. So there are two methods to solve this question. In two methods we can solve this question, my dear. So first let us take the first one. Method 1, I am taking R1 is equal to 300 ohms and R2 is equal to 200 ohms. Okay, method 1 I am taking first. Method 1. Okay, so what is the method 1? R1 is given and R2 is given. So what is the R1, my dear? So R1 is 300 ohms, R2 is 200 ohms. Both are having 1% each. So this is 300 ohms plus or minus 1%. This is 200 ohms plus or minus 1%. Okay. So two resistors are given, right? So two resistors are given, my dear. So two resistors में एक resistor 300 ohms 1% tolerance, second resistor 200 ohms 1% tolerance. So क्या होगा इधर? So 1% means what happens here? This will become as 300 ohms plus or minus 1 by 100 of 300. That means 3 ohms. Either it will become 297 or 303 ohms. Right? Next, this will become 200 ohms plus or minus 1%. 1 by 100 into 200. That means plus or minus 2 ohms. So this will become either 198 ohms or 202 ohms. Okay, wow. So method 1 I am doing now. So if I am taking R equivalent, so what is the R equivalent, my dear? R equivalent will be equal to R1 R2 by R1 plus R2. So if I am taking R1 this two pair, so this is 297 into 198 divided by 297 plus 198. और एक कैटेगरी क्या है? और एक कैटेगरी 303 into 202 divided by 303 plus 202 होगा. So इसके अनुसार आपका वैल्यूज कितना आएगा एक बार चेक करो बेटा, कैलसी यूज करो डेफिनेटली. ओके, टू मेथड्स. या जितने लोग लगे हुए हैं प्लीज स्टे विथ मी टिल द एंड ऑफ द सेशन. ये सेशन आपको बेनिफिट होगा क्योंकि वर्सेटाइल प्रॉब्लम्स मैंने डिस्कस कर रहा हूँ. सो आपको यूज होगा डेफिनेटली. सो 297 इंटू 198 डिवाइडेड बाय 297 प्लस 198. तो ये कितना हो रहा है? 118.8 आ रहा है इधर. तो दिस इज 118.8 आ रहा है. नेक्स्ट ये क्या है? 303 इंटू 202 डिवाइडेड बाई 303 प्लस 202. ये कितना हो रहा है? आपको लगभग 121.2 आ रहा है. So these are the answers, 1182.8 and 121.2. Suppose generally true value क्या है, true value क्या है, that is 300 into 200 divided by 300 plus 200. These are the basic values. So 300 into 200, if you take 300 into 200 divided by 500, it is coming as 120 ohms. So this is the true value. So these are the measurement value 1 and these are measurement value 2. So when I take the percentage error, so percentage error will be measurement value minus true value by true value into 100. So let us take measurement value 1, that is 118.8 minus 120 divided by 120 into 100, or another one क्या है 121.2 minus 120 divided by 120 into 100. So approximately कितना आ रहा है देखो, 118.8 minus 120 divided by 120 into 100. So it is coming as minus 1%, and this one coming as 121.2 minus 120 divided by 120 is also coming as 1%. So plus or minus 1% is the right answer. Excellent, excellent. 1%. सब लोग एक बार मुझे thumbs up दिखाइए बेटा, आपको 1% आ रहा है आंसर. So this 1% is a right answer. Okay, this is method 1 comfortable है. सब लोग को ये method 1 comfortable है? सब लोग को ये method 1 comfortable है? सब लोग को ये method 1 comfortable है or not? Yeah, method 1%. Method 2 भी लेंगे. So let us go for method 2 now. So if you go for method 2, so this is the method 2. What would do the method 2? Anybody? Method 2 is also I'm explaining because exam में अगर 3 resistor दिए तो आपको confusion होगा. Method 2 क्या होगा? That is 1 by R is equal to 1 by R1 plus 1 by R2. Am I right or not? So suppose if I'm doing partial differentiation, minus 1 by R square is equal to minus 1 by R1 square दो R1 by दो R minus 1 by R2 square दो R2 by दो R. So minus gets cancelled. So 1 by R square is equal to 1 by R1 square. So minus gets cancelled na. So I can take here 1 by R into R is equal to 1 by R1 into R1 दो R1 by दो R plus 1 by R2 into R2 दो R2 by दो R. Done. So now I am sending दो R here, दो R by R होगा, and I am sending R here. This will become R by R1, दो R1 by R1 plus R here, that is R by R2, दो R2 by दो R2 by R2 होगा. अगर दोनों से 100 से मल्टीप्लाई किया मैंने, दोनों से 100 से मल्टीप्लाई करो, दो R by R इंटू 100 इज इक्वल टू R by R1 इंटू दो R1 by R1 इंटू 100 होगा ये, प्लस R by R2 दो R2 by R2 इंटू 100 होगा. Got it? So this is percentage error in R. This is R by R1. This is percentage error in R1. This is R by R2. And this is percentage error in R2, my dear. So R already we know that. So what is R? R is equal to 120, true value, that is 120. So this can be taken as 120 divided by what is R1? R1 is nothing but 300. So we can take 300 here. So percentage is 1%. Yes or not? This is 1% only na. So this is also 1%. This is also 1%. Both are 1%. So we can take R is equal to here 120, and this is 200. And this is 1%. So if you take 1% out common, so what is going to happen? 120 by 300 plus 120 by 200. Okay, 120 divided by 300 plus 120 divided by 200. So answer 1% आएगा. So if you take 1% out, it will become as 120 by 300 plus 120 by 200. So इसको simplify करें तो 1 आएगा. So final answer आपको 1% आएगा. मजा आ गया बेटा. तो दिस इज द बेस्ट मेथड. दिस मेथड 2 इज द बेस्ट मेथड, क्योंकि कल एग्जाम में अगर 3 रेसिस्टर्स दिया, R1 R2 R3 3 रेसिस्टर्स दिया, देन डेफिनेटली आपको दिक्कत होगा. सो डेफिनेटली दिस मेथड इज द बेस्ट मेथड. सो आप कमेंट्स के रूप में आप बोल सकते हैं विच इज द बेस्ट मेथड, क्योंकि ये मेथड इज अप्लीकेबल ओनली फॉर 2 रेसिस्टर्स. अगर आपने 3 रेसिस्टर्स लिया, देन दिस मेथड इज अप्लीकेबल फॉर 2 रेसिस्टर्स। अगर आपने 3 रेसिस्टर्स आया क्वेश्चन में, देन ये मेथड पर आप आराम से कर सकते हैं। ऑल ऑफ यू अंडरस्टूड? प्लीज शो मी द थम्स अप एंड एवरीथिंग माय डियर, सो दैट विल गो फॉर द नेक्स्ट क्वेश्चन। जल्दी से जल्दी, या ट्राई टू आंसर दिस क्वेश्चन माय डियर। डन 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 डनाडा डन, फटाफट फटाफट आंसर कर दीजिए बेटा। A moving coil instrument having a resistance of 10 ohms gives a full scale deflection when the current is 10 milliamperes. What should be the value of the series resistance so that it can be used as a voltmeter for measuring potential difference up to 100 volts? Yeah, a moving coil instrument having a resistance of 10 ohms gives a full scale deflection when the current is 10 milliamperes. What should be the value of the series resistance is asking, so that it can be used as a voltmeter for measuring the potential difference of up to 100 volts. So first of all, it is used as ammeter. So if you going for a voltmeter, what is a voltmeter diagram? So for voltmeter we can take like this. This is a voltmeter and this is a meter resistance and this is a series resistance. So this is the basic diagram of our voltmeter. Okay, so I can take this as Bm and I can take this as Rm. Okay, and so this is हमारा मीटर है, ये हमारा मीटर होगा एंड इसको सीरीज में क्या कनेक्ट कर सकते हैं, सीरीज में एक सीरीज रेसिस्टर आएगा. सो दिस इज अवर सीरीज रेसिस्टर. सो आपको पता है आरएससी का फॉर्मूला. सो व्हाट इज द फॉर्मूला फॉर आरएससी? सो आरएससी इज इक्वल टू Rm into m minus 1. Okay, so what is the m? M is equal to V by Vm. So capital V by small vm minus 1. So V is the voltage for which we want to extend the range. Vm is a voltmeter voltage. So in this question what is given? Dekho, he is asking what is the series resistance. So this is a series resistance he is asking, and he wants to extend the voltage up to 100 volts. So he wants to extend the voltage, this is the capital V. So he wants to extend the voltage up to 100 volts. So V is equal to 100 volts, and the meter resistance is given as 10 ohms. The meter resistance is given as 10 ohms, and the current passing through the meter he has given as how much? 10 milliamperes. 10 milliamperes. So this is the 10 milliamperes current going here. So I can calculate the Vm. So Vm is equal to Im into Rm. So Im is equal to 10 milliamperes, and Rm is equal to 10 ohms. So that is 100 millivolts. So 100 millivolts is our Vm. So 100 millivolts is our Vm, my dear. Okay va? So if I'm taking the series resistance value, then we can understand Rm is equal to 10 ohms, capital V is equal to 100 volts, and the small Vm is equal to 100 millivolts. 100 into 10 power minus 3 minus 1. So 100 gets cancelled. 10, this is 10 power 3 minus 1, that is 1000 minus 1, 99990 ohms is the right answer. So series resistor का value कितना आ गया? Series resistor का value 99990 is the right answer my dear. Questions are very clear. Range extension से बहुत सारा अच्छा questions आने की chances है, miss मत करना. चलो, let us go for one more question now. Okay? Yeah, try to answer this question. जल्दी से जल्दी. An ammeter has a current range of 0 to 5. So this question is related to ammeter. So question is related to ammeter my dear. So ammeter means we have to draw the circuit diagram of ammeter. So I am taking the diagram of ammeter. So this is the meter current, this is a meter resistance, and this is a shunt resistance. Shunt resistance comes across. So I can take, so this is our ammeter and this is our shunt resistance. So ये है हमारा IM and this will be our RM and this is our RSH. ये होगा हमारा shunt resistance. So this is our I. So this is our ISH. Okay. So this is our ISH. So what is RSH formula? RSH formula will become as RM by M minus 1. So what is M? M I can take it as I by IM minus 1. Okay va? RSH formula I can take like this. So question में क्या पूछ रहे देखो. A ammeter has a current range of 0 to 5 amperes. So this range is 5 amperes. Okay. and internal resistance of 0.2 ohms. So internal resistance कितना दिया है, 0.2 ohms दिया है, and in order to change the range to 25 amperes, so he wanted to change the range to 25 amperes. Okay, then he's asking what is the resistance we need to add. So shunt resistance we have to add in parallel. So what is the meter resistance? Meter resistance is 0.2 ohms divided by I is equal to 25 divided by Im, that is 5 minus 1. So 0.2, 25 by 5, 5 minus 1, so 0.2 by 4 hoga. So 0.2 by 4 means how much it is? It is going to come as 0.05 ohms. So 0.05 ohms is should become in the parallel with the meter. So option D is the right answer, my dear questions. Option D is the right answer. Chalo, let us go for the next question. Try to answer this question. An average reading digital multimeter reads 10 volts when fed with a triangular wave symmetric about the time axis. What, for the same input, the RMS reading, what is the RMS reading of this meter will be dash? Answer this question. Sumukta Pradhan. This question, so he has given the average reading. So average reading is given as 10 volts. Yes or not? So आपको पता है VRMS. So what is a VRMS? So we know that VRMS for a triangular wave, VRMS is equal to Vm by root 3. Vm by root 3. But in the question what is given is V average. So V average is nothing but Vm by 2. Yes or not? So Vm is equal to 2 times of V average. So that becomes 2 into 10. That becomes as 20 volts. So now the answer will become VRMS will become Vm is equal to 20. So VRMS कितना होगा? VRMS will become as 20 by root 3 होगा. So the right answer is option A. गलत में आप 10 by root 3 देगा. Anybody has given option B? No. Very good. Very good, Har Prasad. Very good, Shubhalit Mandal. Very good. So 20 by root 3 is the right answer for this question. Okay. Now try to answer this question. The bridge method commonly used for finding the mutual inductance is dash. Yes, see here. Sharing bridge is suitable for capacitance measurement. Sharing bridge is for capacitance. DSRT bridge is also for capacitance measurement. And Wien's bridge is for frequency measurement. Wien's bridge is for frequency measurement. So Heaviside Campbell bridge, this is for mutual inductance. So this is for mutual inductance. So the option A is the right answer. So let us go for the next question. Yeah, try to answer this question. A periodic voltage waveform observed on an oscilloscope across a load as shown in the figure. A permanent magnet moving coil PMMC is mentioned across the same load. So he has given a waveform. So 0 to 10 it is a ramp signal, 10 to 12 it is a square wave signal, 12 to 20 is also square wave signal. Options given. Try to answer this question. Four volts, very good. So this is the average. So how to take the average? So I can take the average like this. So V average I can take 1 by T integration of 0 to T. Okay, so what is the this one 1 by T here? So total time period is how much? 20 milliseconds. So total time period हमको 20 milliseconds दिया है. Okay ना? So total period हमको 20 milliseconds दिया है. So from that you can calculate. So 1 by 20, 0 to 10. Okay, so I can take like this. This is 1 by 20 integration of 0 to 10. This is a ramp signal, so I can take T dt plus next this is 10 to 12. This is 10 to 12. And what is this? This is the minus 5 volts. So minus 5 dt plus next this is 12 to 20. So 12 to 20 and this is plus 5 dt plus 5. So if you simplify, what I am going to get, this is 1 by 20, this is t square by 2, 0 to 10 limits, minus 5 t 10 to 12 limits plus 5 t 12 to 20 limits. So 1 by 20, this is 100 by 2, next minus 12 minus 10, 2, 5, 20 minus 2, 8. So this is 1 by 20, this is 50 minus 10 plus 40. 50 plus 40, 90 minus 8, 10, 80. 80 by 20, so the answer is 4 volts. So the right answer is option A is the right answer. Option A is the right answer, my dear. Or else you can go with another method, area and curve method. Area by time. So area we can take half BH plus this area by time also we can take it. Like that also we can do, but this is the standard method. Okay, chalo. Yeah, answer this question, my dear. This question is related to PMMC and as a rectifier. इसका आंसर देखो. So 14.14 sin 314 TV volts 1 kilo ohm is the resistor and 100 kilo ohms is the diode. Here diode is there which acts like a half wave rectifier. So it acts like a half wave rectifier, my dear. So this is the question. This is the resistor here, 100 kilo ohms. So what is the voltmeter? This is the voltmeter connected PMMC. So we know that PMMC measures the V average. Okay, so what is the voltage here? So the voltage output I can take, so V0 I can take it as 100 kilo ohms divided by 100 kilo ohms plus these two resistors are in series, 1 kilo ohm, and the voltage available here is V average, because half wave rectifier, so the half wave rectifier will give the V average. So what is the V average? This is 100 kilo ohms divided by 100 plus 1, 101 kilo ohms. V average means I can take Vm by pi. Okay, so 100 divided by 101. What is the Vm here? The Vm is given as V max, what is 14.14. So I can take it as 14.14 divided by pi. Okay, answer कितना आ रहा है जल्दी बताओ यार. Excellent. So moving for measure both DC as well as, yes, moving iron will measure both DC as well as AC, but in that question he has kept moving iron with along current transformer. Moving, you are asking the previous question, right? Ashutosh Praharaj, you are asking the previous question, right? So 100 into 14.14 divided by 101 divided by 3.14, so that is going to come as 4.458 volts. So 4.458 volts is the right answer. So approximately option A is the right answer. Yes. So previous में आपको match the following में इसमें देखो ध्यान से देखो. Actually as mentioned moving iron through current transformer. So moving iron plus current transformer. What is the meaning of it? Moving iron plus current transformer. Moving iron is only for AC DC, but CT is not for DC. Current transformer is only for AC. That's why it is suitable for AC measurement. क्योंकि अगर आपने क्वेश्चन में ओनली मूविंग आयरन आई तो हम AC DC दोनों ले सकते हैं, लेकिन मूविंग आयरन अटैच विद करंट ट्रांसफार्मर. सो करंट ट्रांसफार्मर इज अ फंडामेंटल इंस्ट्रूमेंट. सो दिस इज हमारा करंट ट्रांसफार्मर. सो करंट ट्रांसफार्मर को पता है ना, करंट ट्रांसफार्मर का डायग्राम. तो ये है हमारा करंट ट्रांसफार्मर. ओके, एंड इसको एक इंस्ट्रूमेंट है. सो करंट ट्रांसफार्मर को एक इंस्ट्रूमेंट है. करंट ट्रांसफार्मर में क्या है? नंबर ऑफ टर्न्स प्राइमरी एंड नंबर ऑफ टर्न्स सेकेंडरी. ओके, सो n1 by n2, so I2 will be less. I is inversely proportional to n. I1 by I2 is equal to n2 by n1. Yes or not? समझ में आपको? So number of turns ज़्यादा होता है. So we are going to attach an instrument here. The instrument is moving iron. He is kept a moving iron instrument. But the input that is coming for the current transformer is AC only, na? That's it. This AC is only scaled. That's why the right answer will go for AC only. So moving iron also will go for AC only. समझ में आपको? Is it clear? If you clear, please tell me clear. Otherwise, don't waste the time. So let us go for the next question. Yeah. Try to answer this question, my dear. Yeah. A balanced Wheatstone bridge ABCD has the following ohm resistances. So RAB. So he has given RAB like this. So this is RAB. Next RBC, next RCD, next RDA. So this is A, this is B, this is C, this is D, this is it. A balanced Wheatstone bridge is having following resistance. RAB has given as how much? 1 kilo ohm plus or minus 2.1%. RBC is given as 100 ohms plus or minus 0.5%. RCD is unknown resistance. Okay, and RDA is given as how much? 300 kilo ohms. This is 300 kilo ohms plus or minus 0.4%. So what is the value of RCD and its accuracy is asking. So first of all, let us take RCD. So what is the balance condition? We know that balance condition is RAB into RCD is equal to RBD into RAB, RBC, RCD, RDA kada. RAB into RCD is equal to RBC, RDA. RBC और DA, RBC और DA, ओके वाह. सो हमको RDA, यस, RAB RCD प्रोडक्ट इज इक्वल टू RBC RDA. तो हमको क्या चाहिए? RCD चाहिए. सो व्हाट इज RCD? RCD इज इक्वल टू RBC इंटू RDA divided by RAB. Okay, so what is the RBC? That is 100 into RDA, that is 300 kilo ohms, divided by RAB, that is RAB is 1 kilo ohm. So I am going to get as 3000, 30,000 ना, बहुत मिस्टेक किया हमने. 1 kilo ohm, 100 ohms, 300 kilo ohms. I think any printing mistake here? I think this should be printing mistake, I think. Clear sir? 100 ohms sir. क्या 100 ohms? कोई मिस्टेक है क्वेश्चन में? RBC into RDA, RBC is 100, RDA 300 kilo ohms, RAB 1 kilo ohm. So it is coming as 30,000 ना, is coming as 30,000. कोई मिस्टेक है क्वेश्चन में? क्वेश्चन में कुछ मिस्टेक होगा शायद. होना चाहिए सर, 300 ohms होना चाहिए. या this should be 300 ohms actually. Let us take 300 ohms. So if you take 300 ohms, then suppose let us take 300 ohms. This is RBC. RBC is equal to 100. So RDA is equal to 300 and RAB is equal to 1000. 1 kilo ohm, 1 cut. Okay, so answer will be 30. Okay, 30. What about the percentage? So RCD is equal to 30 ohms. Am I right? 300 ohms होना चाहिए. Very good, very good. RCD is equal to 30 ohms. Okay, right. So what about the percentage error? So if you can add the percentage error, so the percentage error will be the percentage error for RCD will be the all are division, right? So this is 2.1%, this is 0.5%. So product of quantities and division of quantities में percentage of error will be added. Okay, that means 2.1 plus 0.4 plus 0.5 कितना होता है? 4 plus 5 9 plus 2.1. So 4 plus 5 9 plus 1 10. So 3% है ना? It will be 3%. 0.4 plus 0.5 it will be 3%. So 30 ohms plus 3%. 3% बोलो तो क्या है? 3 by 100. 30 ohms में 3 by 100. 30 into 3 divided by 100. So it is going to come as 0.9 ohms. So 30 ohms plus or minus 0.9 ohms is the right answer. So option B is the right answer. Please make a correction. This is not kilo ohms. Okay, this is not kilo ohms. 11 months ago also you were solving the same question and got the same mistake. Okay. Maybe that is a printing mistake, Mohit Saini. That means I am so happy that you are following me from 11 months. That feels me very good. Okay, that is a printing mistake. No issues. You are more alert. You are more alert in the class. That I am so happy. I am so happy that you are more alert in the class. So, chalo. Thank you, Mohit Sen. Answer this question. Thank you very much. PDF देखते ना हमको PDF में कितना बारा, आपको पता है हमको कितना सेशंस लेते हैं, आपको भी पता है हम कितना सेशंस लेते हैं, लाइव सेशंस लेते हैं एंड आप में सेशंस लेते हैं, यूट्यूब सेशंस लेते हैं, और आपको पता है आई विल टेक केयर ऑफ दीज सब्जेक्ट्स लाइक मेजरमेंट्स, माइक्रो प्रोसेसर्स, सेंसर्स एंड ट्रांसड्यूसर्स. ओके, चलो आंसर दिस क्वेश्चन यार. The AC bit shown in the figure is used to measure the impedance Z if the bridge is balanced for oscillator frequency f is equal to 2 kHz, the impedance Z will be dash. जल्दी से जल्दी बताओ. आंसर ए हो सकता है, क्योंकि देखो ये फर्स्ट ऑफ ऑल ये क्या ब्रिज है, आप ध्यान से देखो, ये एक रेसिस्टर है, ये एक इंडक्टर एंड रेसिस्टर है, एंड इसका कंपनसेशन हो गया इधर कैपेसिटर एंड दिस इज आल्सो प्रिंटिंग मिस्टेक, आई एम सॉरी, द डिटेक्टर शुड नॉट बी हियर, should be here. Okay, so if you check the questions here, so this inductor and resistor and this capacitor and resistor are compensated, so definitely it should be resistor. It is what bridge actually? It is a Maxwell inductance capacitance bridge. So for a Maxwell inductance capacitance bridge, actually here will be the test coil and test resistor, and here comes another resistor, here comes another resistor, and here we will be having coil, will be having resistor and capacitor. Okay, so it is Maxwell inductance capacitance bridge or Hayes bridge. जल्दी बताओ बेटा, it is Maxwell inductance capacitance or Hayes bridge? Anybody please tell me, is it Maxwell inductance capacitance or Hayes bridge? Is Hayes bridge? Am I right or not? Maxwell inductance capacitance में capacitor will be in parallel. So this is Hayes bridge. Actually this is Hayes bridge. This is Hayes bridge, and this is capacitor parallel में आता है. This is Maxwell inductance capacitance bridge. But whatever, the inductive reactance will be cancelled with capacitive reactance. The inductive reactance will be cancelled with capacitive reactance. So the resistor should be here, be resistor only. So definitely here there should not be any reactive part. There should not be any reactive part. This is a Hayes bridge. You understand? So the reactance with inductance, the reactance with capacitance, both are cancelled. So here we should get the resistance only. So the right answer is, it should have only resistance part, it should not have imaginary part, option A. Or else if you want to do, you can go with another method, Z1 Z4 is equal to Z2 Z3 मेथड यूज करके भी आप कर सकते हैं, लेकिन एग्जाम में क्या होता है, आपको टाइम वेस्ट होता है. थोड़ा सा कॉन्सेप्चुअली यूज करो, or else you can follow Z1 Z4 is equal to Z2 Z3, क्योंकि this is रियल एंड इमेजिनरी पार्ट का कॉन्सेप्ट है. क्लियर माय डियर स्टूडेंट्स? इज इट क्लियर? Chalo mo, let us go for the next question. Try to answer this question. The bridge circuit shown in the figure below is used for the measurement of an unknown element Zx. The bridge circuit is best suited when Zx is dash. Just before only I told you it is a Maxwell inductance capacitance bridge, MIC. So Maxwell inductance capacitance bridge, what should we have? It will be what? It cannot be resistance, it can be inductor. Why? Because just before I told you this is an inductor, so we can keep the inductor here. Low quality factor. Yes. Chalo, let us go for the next question. Try to answer this question. 2 wattmeter method is used for measurement of power in a balanced 3-phase load supplied from a balanced 3-phase system. If one of the wattmeters reads the half of the other, then the power factor is dash. This. Okay. So 2 wattmeter method. Option D is the right answer. Okay, let us see. So what is the formula we can use? The formula is tan phi. So tan phi is equal to root 3 into W1 minus W2 by W1 plus W2. So what is saying, if one of the wattmeter reads half of the other, one of the wattmeter reads half of the other. So let us take W1 is equal to half of the W2. So what I can, or it will be negative, right? So you can take W2 is equal to half of the W1. W2 is equal to half of the W1. Then what happens? This will be root 3. So W1 minus half of this W1 divided by W1 plus half of W1. So if you simplify, this is root 3. So this is half W1 minus this is 3 by 2 W1. So it gets cancelled, 1 by 2, 2 by 3. So root 3 into 1 by 2 into 2 by 3. So that will become root 3, 1 by root 3. So phi is equal to 30. So tan phi is coming as 1 by root 3. So phi becomes 30. Cover factor cos phi. Cos phi means cos 30. Cos 30 means root 3 by 2, 1.73 by 2. 1.73 t by 2, that becomes as 0.866. 0.866. Okay, option D is the right answer. Chalo, let us go for the next question. Yeah, try to answer this question. A wattmeter is connected as shown in the figure. The wattmeter reads dash. See here, generally what is the power? Power is nothing but VPC ICC cos phi. So जो current यहाँ जा रहा है, the same current is also traveling to Z2, but the potential coil is connected across Z2. So potential coil is connected across Z2 means that is V Z2 and the current is passing through Z2 and cos phi. So most important point is the potential coil, where the potential coil terminals are connected. Potential coil terminals are connected across Z2. So it reads the power consumed by the Z2, my dear. Power consumed by the Z2. Okay. So try to understand. This is a formula. What is to measure the power? We need the voltage of the pressure coil. We need the current of the current coil. Okay. So let us go for the next question. Answer this question. आवाज आ रहा है बेटा? और गेटिंग माई वॉइस क्लियरली? सुमुख का प्रधान या इसका क्या आंसर क्या है? पावर कंज्यूम्ड बाय अ बैलेंस्ड three phase 3 wire load is measured by 2 wattmeter method. The first wattmeter reads twice of the second. First wattmeter reads the twice of the second. W1 is equal to W2. Then he's asking the load impedance angle. So we'll go for tan phi. So tan phi is equal to √3 into W1 minus W2 divided by W1 plus W2. Am I right or not? So the same formula we can use it, no issues. So what he has mentioned here, so this is √3. So what is the W1? That will be 2W2 minus W2 divided by, this is 2W2 plus W2. So this is 2W2 minus W2, W2 by 2W2 plus W2, 3W2. So this W2 gets cancelled. So now I'm going to get √3, that is 1 by √3. So tan phi is equal to 1 by √3. So phi is equal to 30 degrees. So 30 degrees in radians he is asking. So we know that clearly 360 degrees is equal to 2 pi radians. Okay. So 1 degree is equal to pi by excuse me, 180 radians. So he's asking 30 degrees. So 30 degrees means pi by 180 into 30. So that will become as pi by 6 radians. So the right answer is here pi by 6 radians. Option C is the right answer. Angle negative कैसा हो सकता है भैया? cos phi है ना? cos phi. We are going to take cos phi, right? Power factor is cos phi. Power factor is cos phi. So cos of minus phi is also cos phi. no issues. Cos of -5 is also cos 5 हो सकता है. See my dear students, here one comparison I want to give you so that it will be useful for your exam. So here let us take 5. So here we take power factor cos 5. Okay. And here we'll take the wattmeter reading. W1 क्या हो सकता है and W2 क्या हो सकता है, and we can take the comments. Okay, comments. Let us take the comments also. Okay, so basically we got these all formulas from the fundamental. W1 is equal to VL IL cos of 30 minus 5. W2 is equal to VL IL cos of 30 plus 5. So from all these formulas we got it. Suppose if I am taking power factor is unity 0, okay, 0, then power factor is equal to cos 5. Cos 5 is equal to 1, unity power factor. So if I am taking this, both are same, cos 30 होगा. So W1 will be root 3 by 2 VL IL होगा. This is also root 3 by 2 VL IL होगा. That means W1 is equal to W2. Unity means equal. If power factor is unity, this will be equal. W1 is equal to W2. If this is cos 5 is equal to 1, unity means both the power factors are equal. Both the wattmeter readings are equal. Okay. Now let us take 30 degrees. Then cos 5. Cos means cos 30. Cos 30 means 0.866. Cos 30 is root 3 by 2. So if you take 30 degrees, this will become 30 minus 30 cos 0. That becomes VLIL. This becomes VLIL. And this is 30 plus 30 cos 60. Cos 60 means this becomes VLIL by 2. So what is happening here? One of the wattmeter is equal to first wattmeter reading. So second wattmeter reading W2 is equal to half of the first one. Half of the first one. W2 is equal to half of the W1. Next let us take 60 degrees. So cos 5 cos 60, that is 0.5. Okay, cos 60, that is 0.5. So if I take the cos 60, you can take now 30 minus 60 minus 30. Cos of minus 30 means cos 30. So that becomes again root 3 by 2 VL IL. And next 30 plus 60. 30 plus 60 means 90. Cos 90 is 0. So one of the wattmeter reading is 0. One of meter reading is 0. So for 60 degrees. So now if I am going for 90 degrees, cos 5 cos 90 is equal to 0. Okay. So if you take 90 here, 30 minus 90, 30 minus 90 minus 60. Cos of minus 60 means cos 60. Cos 60 means 1 by 2. That means VL IL by 2. Next, this is this will be what? 30 plus 90. 30 plus 90 means cos 120. So cos 120 means how much? Minus. So it will become minus VL IL by 2. That means one of the wattmeter reading is negative. One of meter is negative. Do you understand? So this is the hint to remember. So if you take 0.5 as a reference, my dear, let us take the 0.5 as a reference. So above 0.5 one case is there and below 0.5 another case is there. So this is above 0.5 and this is the below 0.5. Okay. So this is above 0.5, this is below 0.5. Wait. Above 0.5, below 0.5. Sir, what is the angle? From the above, W1 always greater than or equal to W2. From the above, W1 always greater than or equal to W2. Yes. Yes. See here. First meter. Either they are equal or greater. So here positive. So you can remember like this. These are the positive. These are the 0, negative. Ante above 0.5 the readings are positive. Below 0.5 the readings are negative. At 0.5 0. One of the meter reading is 0. Like this you can remember. Okay, va? Is it clear, GATE aspirant? Above this positive, below this negative, at 0.5. 0.5 you can take it as a reference. 0.5 you can take it as a reference. Clear हो गया आपको? Third standard. 3. 1, 2, 3. Eight. Chalo, let us go for next question. Answer this question. The pressure coil of dynamometer type wattmeter is dash. Try to answer this question. Yes, my dear. Option. The pressure coil of dynamometer type wattmeter is dash. Highly inductive, highly resistive, purely resistive, purely. So he is asking pure and highly both. So सोच के बताइए बेटा. We cannot expect pure resistive or pure, but highly resistive we expect. So this is what we expect. Highly resistive is option B is the right answer. See, I will tell you. So this is our current coil. So this is the load. Okay, this is the load, and this is our pressure coil. So this is the pressure coil, this is a current coil. We expect pressure coil to be purely resistive. We expect pressure coil to be purely resistive, but it's not possible. But inductance will be there, but inductance effect will be there. So at least we expect highly resistive. That's why due to inductance of the coil, highly resistive hona hai. So to compensate the effect of capacitance, effect of inductance, okay na, we expect them as purely resistive, but highly resistive. Actually purely resistive hona hai, but pure resistive is not possible. So practically what happens, inductance is going to be like this. So if it is a pure resistive, the VR and IR both will be in the same line. Okay, so it is neither purely inductive also. Purely inductive means should be like this. So VL should become like this. Okay, wow. So it cannot be like that because of inductance effect we are facing the problem. So to compensate effect of inductance, we'll keep parallelly a capacitor. So the capacitance value is 0.41 into R by L square. Okay, so that is a formula, 0.41 into L by R square, 0.41 L by R square. This is the value we are going to keep. 0.41 L by R square we are going to keep. Okay, wow. So highly resistive is the answer. Most of all the students has given option B. We expect highly resistive, but practically it is not possible. Is it clear, Subhat Mandal? All of you clear? Yes or no? Yes. So let us go for the next question. Answer this question. आंसर बताइए भाई. Option D. Okay. A stationary closed Lysage's pattern on oscilloscope has 3 horizontal tangencies and 2 vertical tangencies. So we have a formula: frequency of y-axis, frequency x-axis is equal to number of horizontal tangencies divided by number of vertical tangencies. Horizontal tangencies to vertical tangencies. So input frequency, vertical tangents for a horizontal frequency, horizontal input frequency means fx. So fx is given 3 kilohertz. Fx is given how much? 3 kilohertz. Okay, so fy by this is 3 kilohertz, and number of horizontal tangents is 3, number of vertical tangents is 2, so this is 1.5. So frequency applied to the vertical input is equal to 1.5 into 3 kilohertz, so that will become as 4.5 kilohertz. So what is the right answer? 4.5 kilohertz is the right answer. Option D is the right answer, my dear. Yes, Sai Chetan, कहाँ से हो आप? Try to answer this question. Consider the following statements. Statement 1: the compensating coil of a low power factor wattmeter compensate the effect of impedance of the current coil. The compensating coil of a low power factor wattmeter compensates the effect of the impedance of the voltage coil circuit. Statement 1 is true, 2 is false, 1 is false, 2 is true. Both 1 and 2 are true. So think and tell me the answer. यस, ऑप्शन ये बोल रहे हैं. सी हियर, the compensating coil of a low power factor wattmeter means lagging power factor. So compensate the effect of the impedance of the current coil. No effect of the current coil. Current coil is purely resistive. Current coil is resistive actually. Current coil में problem क्या है? कुछ भी problem नहीं है. It allows the current ना. So current coil का diagram क्या है? R is equal to rho L by, if we take current coil is thick in size. So current coil is thick in size. Current को allow करना है ना. So if you see the current coil, if you see, so size is more thick in size and shorter length. Shorter length. So what happens? So R is equal to rho L by A. So area is more, resistance is less. So it is not having much effect. It is a current coil. So current coil में कुछ problem नहीं है. Problem कहाँ होते हैं हमका? Voltage coil, pressure coil. Pressure coil is purely pressure coil we expect to be highly resistive, but it is having inductance effect. Inductance effect is the most important problem for the pressure coil. Inductance effect of the pressure coil है. Pressure coil को inductance effect है. We expect resistive, but it is having inductance effect. इसकी वजह से हमको प्रॉब्लम आ रहा है, इसको कंपनसेट करना है. सो दैट्स व्हाई द कंपनसेटिंग कॉइल ऑफ ए लो पावर फैक्टर मीटर कंपनसेट्स द इफेक्ट ऑफ द इंपेडेंस ऑफ द वोल्टेज कॉइल सर्क्यूट. सो स्टेटमेंट 2 इज ट्रू. स्टेटमेंट 2 इज ट्रू, 1 इज फॉल्स. ऑप्शन बी इज राइट आंसर. ऑप्शन बी इज राइट आंसर. शुभजीत मंडल. करंट कॉइल से हमको कुछ प्रॉब्लम नहीं है. हमको प्रॉब्लम कहां से होता है? हमको प्रॉब्लम प्रेशर कॉइल से होता है. हमको प्रॉब्लम कहां से होता है? प्रॉब्लम प्रेशर कॉइल से होता है. प्रेशर कॉइल इज इंडक्टिव इन नेचर. सो बिकॉज ऑफ दैट इंडक्टेंस नेचर ओनली वी आर गोइंग फॉर कंपनसेशन टेक्निक्स. समझ में आपको? चलो लेट अस गो फॉर द नेक्स्ट क्वेश्चन. आंसर दिस क्वेश्चन. Yes, horizontal axis. In oscilloscope, linear sweep. See, test signal is applied. Test signal is applied to vertical axis, and time signal or time based signal is applied. Time signal is applied to horizontal axis. Horizontal axis. So option B is the right answer. Okay. Now let us go for the another question. Try to answer this question. The current is measured in electrical circuit as 5 amperes with accuracy of plus or minus 0.5%. This current is flowing through a resistor of 5 ohms plus or minus 0.25%. The power dissipated in the resistor will be dash. Yeah, see here, the current is measured in electrical circuit as 5 amperes. So current is given as 5 amperes. See here, what is the information? You try to understand. The current is given as 5 amperes with accuracy of plus or minus 5.5%. Okay, done. Next, the current is following through resistor. Resistor is equal to 5 ohms plus or minus 0.25%. So the power is asking, power is equal to what? I square R, we know that very well. So first of all, I square R, 5 into 5 into 5. So 5 square into 5, so that becomes 125. And the power, whatever the percentage errors, we can add the percentage errors. 0.5 plus 0.5 plus 0.25. Why? Because I 2 times. So 125 plus or minus 1.25. So percentage, this is 125 plus or minus 1.25 percentage. Option B is the right answer. Option B is the right. Simple questions, ऐसा questions miss मत करना. चलो, let's go for another question. Try to answer this question. The current in the two branches of the circuit is equal to I is equal to I1 plus I2. Okay. So if the value of I1 is equal to 80 plus or minus 2 amperes, I2 is equal to 120 plus or minus 1 ampere. The value of I, very simple question, that is 200 plus or minus 3 amperes. With the limits of error given as standard deviations. Limits of error is given as standard deviation. How much it is coming here closely? Option B or A? थ्री एम्पियर्स आएगा ना, absolutely. चेक करो बेटा. Follow the standard deviation method. We'll follow the standard deviation method. Just a wait. So this is I is equal to I1 plus I2 na. So I is equal to I1 plus I2. So we can calculate dou I by dou I1. That will become as 1 Next, dou I by dou I2, that will become as 1. Standard deviation in I1, he has given in terms of standard deviation, that's why I'm taking. Sigma I1, that is 2 amperes, and sigma I2 he has given as how much? 1 ampere. Okay, so now I will do the uncertainty in I. Okay, so sigma in I want, that means I can write like this: dou I by dou I1 whole square sigma I1 whole square dou I by dou I2 whole square sigma I2 whole square. एक बार चेक करके बताओ बेटा इसका आंसर कितना आ रहा है. So dou I by I1, that is 1, and sigma I1, that is 2 square, plus dou I by I2, that is 1 square, sigma I2 1 square. So कितना आ रहा है? 4 plus 1 root 5. So root 5 means how much it is coming? एक बार चेक कर लो, कैल्स यूज करके चेक कर लो बेटा एग्जैक्टली कितना आ रहा है. आई थिंक दिस इज रॉन्ग आंसर नाउ, बिकॉज very close answers are given na. So he has mentioned standard deviation, so square root of 5, it is coming as 2.23. so option D is the right answer. Option D is the right answer, my dear. Please mention here if the limits of error is given as not absolute errors. See, this is, it is not delta I. If it is delta I, we can take like this: if delta I is equal to 2 amperes, delta I is equal to 1 ampere, then this method is right, absolute error. This is absolute error, but this is not absolute error. It is mentioned this as standard deviations, so we have to go for this. Is it clear, my doston? Agar it is absolute error, then you can go for this. If it is mentioned this 2 amperes and 1 amperes are absolute errors, you can go for this, but these are not absolute errors mentioned. Is mentioned it as standard deviation, so that's why I'm going for this method. So this cannot be the answer, this will be the answer. Is it clear? शुभजीत मंडल, जितने लोग लाइव में देख रहे हैं मुझे एक बार थम्स अप दिखाए बेटा, कंफर्मेशन दिखाए बेटा. एंड आप सब लोग कब जा रहे हैं एग्जाम? व्हेन इज योर एग्जाम? हाउ मेनी ऑफ योर electrical and instrumentation students? And tomorrow morning I am going to take microprocess sessions also. That microprocess session is only for EC students. Tomorrow morning 7 बजे भी मैं आ रहा हूँ microprocess session लेके. Okay. Yes sir, yes sir. So जितने लोग लाइव में मुझे एक बार थम्स अप दिखा बेटा. आपका एनर्जी बहुत इंपॉर्टेंट है. कब है एग्जाम आपको? कल मॉर्निंग 10 बजे को स्टार्ट है ना एग्जाम जी. चलो आंसर दिस क्वेश्चन. The voltage is measured across a resistor by following current through it. The reading of ammeter is given, the resistance is given, the voltage reading is dash. Try to answer this question. Make it fast. ऑप्शन बी बोल रहे हैं. ओके, सी हियर, a voltage is measured across a resistor R is equal to V by I. So what is measured? Ammeter, so he is asking voltage. Okay, voltage reading. So V is equal to I into R, product. So but absolute values are given. So I is equal to what is given? I is equal to 10 plus or minus 0.2 is given. So how much percentage? You can convert that into percentage ना. 10 में कितना percentage 0.2 होगा? Okay, 10 में कितना percentage 0.2 होगा? So x is equal to how much? 100 into 0.2 divided by 10, that becomes 2%. So this can be written as 10 plus or minus 2%. Next R is given as how much, my dear? Resistance is 12.5 plus or minus 0.25 ohms. So 12.5 में कितना percentage? X by 100 will become as 0.25. So that will become as 100 into 0.25 divided by 12.5, that becomes 2%. This is also 2% here. Okay, let us take this y. Okay, this is y. All of you following? So what I am doing, I am converting into percentage. 125 में कितना percentage will become as 0.25. Okay, so y is equal to 25 by 12.5, so it becomes 2%. Both are 2%. So both are 2%. Okay, so what is a V? V is equal to I into R. So V is equal to I into R means I is this, R is this. So 10 into 12.5 plus or minus that percentage. For product of quantities, the percentages will be added. Na? This answer is not matching. So it should be 2 plus 2, 2% plus 2%, 4% should come na. So 125 plus or minus 4% should come, but it's not matching. So option B will be the closest. Any mistake? Option B. Maybe it is, suppose if you take 12 ohms, it is going to become as 2.08%, then 2.08 plus 2, 4% is the closest. Option B is the closest answer. Yes or no? So let us go for the next question. Answer this question. Assume 2 meters A and B requires 20 milliamperes and 10 milliamperes respectively to give full scale deflection. Then sensitivity, option A, sensitivity independent of full scale deflection. Option B, both A and B are equally sensitive. Option C, A is more sensitive. Option D, B is more sensitive. Answer बताओ बेटा जल्दी. even देखो 20 milliamperes is a full scale deflection, so sensitivity is always inverse of full scale deflection. Okay na, sensitivity always inverse of full scale deflection. So V is equal to, actually sensitivity का units पे ऐसा होता है, V is equal to IR, this is 1 by volt per ohm, so this becomes as ohm per volt. V is equal to IR, I is equal to V by R, so volt per ohm, so sensitivity will become as ohm per volt. Okay, so first sensitivity कितना होगा, 1 by 20 milliamperes. So 1 by 20 milliamperes, so that will become as how much? 1 by 20 means 1 by 2 means 0.5, this is 0.05. okay, 0.05 milli ohms per volt होगा. So second sensitivity कितना होगा, sensitivity is 1 by 10 milliamperes, 10 milliamperes, that is 0.1. okay, 0.1 milli ohms per volt होगा. okay, so which is more sensitive now? Which is more sensitive? Which is more sensitive? So this will be the more sensitive, yes or not? So S2 is greater than S1, so B is more sensitive. Option B is right answer. Very good my dear students. Yes, Subhajit Mondal, are you there? Everybody is there. एक बार क्या हो गया, आंसर्स नहीं आ रहा आपसे साइड से? Are you giving the answers or not my dear? आंसर्स नहीं आ रहा आपके साइड से? सुभजीत, अजय कुमार, खड़गपुर IIT, जितने लोग लाइव में देख रहे हैं मुझे कंफर्मेशन कर दीजिए बेटा, आंसर्स नहीं आ रहा आपके साइड से. yes, S2 is more than S1. चलो let us go for the next question. Which of the following defines the bridge sensitivity of the Wheatstone bridge? Bridge sensitivity of the Wheatstone bridge. सोच के बताइए बेटा, जल्दी से जल्दी. में भी ऐसे क्वेश्चंस आ सकते हैं. यस यस, सी मेजरमेंट्स इज ऐसा सब्जेक्ट है, मेजरमेंट्स इज अ वेरी फंडामेंटल सब्जेक्ट एंड हमको वर्सेटाइल नंबर ऑफ क्वेश्चंस आने की चांसेस है मेजरमेंट्स में, क्योंकि बहुत सारा मेजरिंग इंस्ट्रूमेंट्स है, पीएमएमसी है, मूविंग आयरन है, डायनामोमीटर है, एनर्जी मीटर है एंड एरर एनालिसिस भी है, बहुत सारा टॉपिक्स है ना, वो टॉपिक्स में आपको बहुत सारे क्वेश्चंस आने की चांस है. देखो बेटा, so which of the following defines a bridge sensitivity? So what is a bridge sensitivity? V bridge is equal to Vs by 4 into delta R by R. Okay, so if you take, this cannot be the answer. Why? Because this cannot be the output. This cannot be the output. Output is always deflection. So these both are wrong. So the right answer will be in this. So generally what happens is this, if we consider as a deflection, we consider this as a deflection in galvanometer, and this is Vs by 4 into delta R by R. So we can take, so theta by delta R by R and per unit change in resistance. So this is what we call as the sensitivity of the bridge. This is the right answer. Anybody any doubts, you can ask me here. Why? Because this type of question sometimes will come in the IES paper. My dear. If you're clear, my dear, chalo, let us go for one more question. Answer this question. Which of these statements is not correct? Dekho, statement A, deviation from the true value of the measured value is called an error. The smallest change in measured value to which the instrument will respond is called resolution. The ratio of the output signal or response of the instrument to a change of input or measured variable is called sensitivity. The smallest change in the measured value to which the instrument will respond is called deviation. Answer batao beta, jaldi se jaldi. See, the deviation from the true value of the measured value is called error. That is correct only. So error is equal to measurement value minus true value. So this is true statement. So this is true. Next, the smallest change in the measured value to which the instrument will respond. The smallest change in the measured value to which the instrument will respond is called resolution. The ratio of the output signal or response to the instrument to a change in input is called sensitivity. This is also correct. The smallest change in measured value to which the instrument will respond is called deviation. This is wrong. So this is sensitivity. Sensitivity is equal to delta y by delta x. This is also correct. So this is also correct. So this is wrong statement. Okay. So he is asking the wrong statement. So option D is the wrong statement. Am I right? Option D is going to be the wrong statement. So D will be the answer. Thank you very much. Thank you very much. Let us go for the next question. Very simple question. This is the instrument that reads only average quantity will be dash. Induction type ammeter, PMMC, moving iron voltmeter, rectifier type. What is the answer? जल्दी से जल्दी बताओ बेटा. The instrument that reads only average value. Yes, PMMC is only average value. So let's go for next question. Answer this question. The bridge is shown in the figure below. If the value of resistances in arm AB is equal to the resistance in arm AD, that means R1 is equal to R2, and the capacitance in arm AB and AD, then if the bridge is balanced, then the value of resonant frequency is dash. Answer this question, my dear. For this question, what is the answer? It is what bridge? Can anybody tell me? It is what bridge? Can anybody tell me? सोच के बताइए बेटा जल्दी. माइक चले गया. See, this is the formula, right? Actually, means bridge का formula ये आएगा 1 by square root of R1 R2 C1 C2. If you want, you can balance it. You can check it. Okay. You want, you can check it like this. Z1 is equal to. You want, you can check it. No, not a issue. Okay. So what is a Z1? Z1 is equal to R1 parallel with 1 by j omega C1. So that will become as R1 into 1 by j omega C1 divided by R1 plus 1 by j omega C1. So this is R1 by, this is 1 plus j omega R1 C1. Next, this is next R2. R2 is series combination. Z2 is, let us take Z2 is series combination of R2 and C2. So R2 plus 1 by j omega C2. So that becomes as 1 plus j omega R2 C2 by j omega C2. Z3 is R3, Z4 is R4. Am I right? Z3 is R3, Z4 is R4. So what I am going to get, Z1, Z4 is equal to Z2, Z3. If you simplify and if you do calculation, Sound is coming now? Suvajit Mandal. If you do simplification of all these things, so if you substitute this R1 1 plus j omega R1 C1 and this one 1 plus j omega R2 C2, this one and everything, if you simplify, so omega you will get 1 by root of R1 R2 C1 C2, so 2 pi f. So actually Wien's में frequency आएगा, that is 1 by 2 pi square root of R1 R2 C1 C2. If R1 is equal to R2 is equal to R, C1 is equal to C2 is equal to C, so this will become as 1 by 2 pi RC. That's it. Frequency is equal to 1 by 2 pi RC hoga. So option A is the right answer. Option A is the right answer. Okay, let us go for the next question. Can you answer this question? Owen's bridge beta, this is Owen's bridge shown in the figure, is used for the measurement of impedance of the steel specimen, okay, from arm AB. So this is arm AB. For source supply frequency of 4 kHz, bridge attends balances with test specimen. Its other branches are given. Can you solve this question? Can you solve this question, my dear? Owen's bridge. So first of all, what is a Z1? Z1 is equal to R1 plus j omega L1. Okay, next. Z2 is equal to R2 plus 1 by j omega C2. Okay, next. Z3 is equal to R3. Z4 is equal to 1 by j omega C4. So first we have to calculate what is asking the value of time constant arm AB. So our time constant means you need L1 by R1 is a time constant. So we have to find out the L1 and R1 values. Anybody has done this calculation? Anybody has done this calculation? So please make go ahead. Z1 Z4 is equal to Z2 Z3 करो. So Z1 क्या है? R1 plus j omega L1 into Z4, that is 1 by j omega C4. Z2 क्या है? R2 plus 1 by j omega C2. Z3 क्या है? R3. So simplify करो बेटा, कितना आएगा? So I can take the simplification as R1 plus, see sometimes BARC exam है, somewhat lengthy questions also expected. R1 plus j omega L1 by j omega c4. This is j omega c4 here. This is j omega c4 is equal to 1 plus 1 plus j omega r2 c2 into r3 whole divided by, okay, j omega c2. J omega c2, am I right? So here j omega gets cancelled. J omega gets cancelled, my dear. So I can write r1 plus j omega l1, simple only, c2 is equal to 1 plus j omega r2 c2 r3 c4. Okay, so I can write here r1 c2 plus j omega l1 c2. This is r3 c4 plus j omega r2 c2 r3 c4. So compare the real. R1 c2 is equal to r3 c4. So r1 is equal to r3 into c4 by c2. Okay, next L1 c2 is equal to r2 c2 r3 c4. C2 gets cancelled. L1 is equal to r2 r3 c4 beta. So please calculate L1 and R1 and tell me the time constant. Time constant is L1 by R1. फटाफट जल्दी बताओ बेटा, आप कैलकुलेशन करके बताओ, इसमें कोई ऑप्शन नहीं है, ऑप्शन फिल इन द ब्लैंक है, जल्दी बताओ, करके बताओ बेटा, आई एम वेटिंग फॉर योर आंसर. साउंड आ रहा है सुभजीत मंडल? जल्दी से बताओ बेटा, उसका आंसर जल्दी से बताओ, कितना आ रहा है आपको, कैलकुलेट करके बताओ बेटा. R1 कितना आएगा? R3, what is R3 here? R3 is 100 ohms. R3 is equal to 100. Next C4 कितना है? C4 is 1 microfarad. C4 is 1 microfarad. Next C2 कितना है बेटा? C2 is 0.5 microfarad. C2 is 0.5 microfarad. So micro खत्म. 5 by 10, 1000 by 5, 1000 by 5, 1000 by 5, 1000 by 5. This is 1000 by 5. That will become as 200 ohms. 200 ohms. Next L1. R2 कितना दिया बेटा? R2 540. So R2 is equal to 540 into R3 कितना दिया बेटा? 100. This is given as 100. And C4 कितना दिया बेटा? C4 is 1 microfarad. 1 microfarad. So कितना होगा this one? 1 micro. That is a 10 power minus 6. So 1, 2, 3 cut minus 3 होगा. So 54 millihenry. So 54 millihenry. So time constant is equal to L1 by R1. So this is 54 millihenry divided by 200. So 54 divided by 200. कितना आ रहा है भैया, जल्दी बताओ. It is coming around 0.27. 0.27 milliseconds आ रहा है. Am I right? 0.27 milliseconds आ रहा है. जितने लोग को आंसर आता है जल्दी बताओ. 0.27 milliseconds is the right answer. Is it right? Yes sir, no बेटा. सुभजीत, जितने लोग लाइव में जल्दी बताओ यार. 0.27 milliseconds आ गए मुझे आंसर. Yeah, try to answer this question. Yes or no? Try to answer this question फटाफट. Find the excitation frequency and the value of the resistance R2. R2 in the AC bridge is shown in figure under balance condition. The circuit components are given. So R1 is given. R1 is given as how much? 5K. And R3 and R4 is given as 10K. And C1 is equal to 5C2. Okay, 1 microfarad. C1 is equal to 5C2 is equal to 1 microfarad. तो सोच के करो ये बेटा, ये जरा टेक केयर ऑफ, डू इट, मेक इट फास्ट. आई एम वेटिंग फॉर योर आंसर. चलो आंसर प्लीज. Same like this only, right? Same like Wien's bridge only, right? R1C1 parallel, R2C2 series. So same here also. So what is answer? We can directly write it's a Wien's bridge. So W is equal to 1 by square root of R1 R2 C1 C2. So you can calculate now. प्लीज कैलकुलेट, जल्दी से जल्दी बताओ. आंसर कितना आ रहा है भैया? इधर हार्ड क्वेश्चन नहीं है बेटा, सिंपल क्वेश्चन है. R1 दिया है आपको. He has mentioned that excitation frequency and the value of resistance R2 in the AC bridge shown in the figure under balanced condition. The circuit components are given. So here this F is equal to 1 by 2 pi स्क्वायर रूट ऑफ R1 R2 C1 C2 ना. So R1 कितना दिया है 5K, R2 we have to find. So you can substitute that, which is matching. You can go ahead. You can go with comparison, yaar. We can go with comparison. No need to solve. Okay. But this is also very simple. You can go with comparison. Okay. See, C1 is equal to 5C2. C1 is equal to 5C2. That is 1 microfarad. C1 is equal to 5C2. So 5C2 into 5C2. That is 5 microfarad. C1 is 1 microfarad. So C1 is equal to 1 microfarad. C1 is equal to 5C2. 5C2 is equal to 1 microfarad. And C2 is equal to 0.2 microfarad. 1 by 5. Okay. So you can substitute like this. This is 10 to the power of minus 6. This is 0.2 into 10 to the power minus 6. Okay. R1 is how much? 5K. So 5 into 10 power 3. So like that you can substitute. So F is equal to 1 by 2 pi square root of, this is 5 into 10 power 3. R2 you don't know, but C1 you know na. C1 is 10 power minus 6. This is 0.2 into 10 power minus 6. Now you just substitute the R2 value from this. You substitute R2 value, match it. Whichever is matching you can check it. Okay. So please check it. Please check this value. For example, let us take 6.25K. So 6.25K, if I take 5 into 6.25 into 10 power 6 into 10 power minus 6 into 0.2 into 10 power minus 6. So square root of answer is coming 2.5. So it is not matching. So like that you can compare. I will take 12.5K. Okay. 5 into 12.5 into 10 power 6 into 10 power minus 6 into 0.2 into 10 power minus 6. Square root of answer into 2 pi 6.28. 1 divided by answer 45. It is not matching. Okay. ये दोनों में होगा ऑप्शन. 5 into 6.25 into 10 power 6 into 10 power minus 6 into 0.2 into 10 power minus 6. Square root of answer into 6.28. 1 divided by answer 63 आ रहा है. This one you can check it. Please check this. This is matching. Option A is matching. Option A is matching. Check करो एक बार. Option A matches. Check करो. So like that you can solve. Okay. So let us go for simple question. This is Wagner's earth device in AC circuit is used for dash. Wagner's earth device, eliminating the effect of earth capacitance, eliminating the effect of intercomponent capacitance, eliminating the effect of stray electric field, shielding of bridge elements. सोच के बताइए बेटा जल्दी से जल्दी. Wagner earth, it is used in the bridges, AC bridges. What is the right answer? What is the right answer for this question? Yes, eliminating the effect of earth capacitance. Option A is the right answer. Okay. It is not related to electrostatic fields. It's not related to this. Earth capacitance को eliminate करने के लिए हमने Wagner earth circuit we are using. Okay. चलो let us go for another question. Answer this question. A certain dynamometer ammeter, the mutual inductance M varies with deflection theta. So M is given. What is M? That is minus 12 cos of theta plus 10 degrees millihenry. Find the deflecting torque produced by a direct current of 25 amperes corresponding to a deflection of 50 degrees is dash. So how to do this? Its question is related to dynamometer ammeter. So TD is equal to I square dm by d theta. That is the thing. So first of all, M is given, so we can calculate the dm by d theta. Dm by d theta we take. Okay. So this is cos means minus sine. So minus of sine theta plus 10. That's it. So that will become as plus 12 sine of theta plus 10. Okay. For a deflection, if theta is equal to 50, so dm by d theta kitna hoga my dear? Dm by d theta will become as 12 sine 50 plus 10. So that comes sine 60. Am I right? So sine 60. So sine 60 means root 3 by 2. So root 3 by 2 aa gaya. So 25 into 25 into 0.866. So the answer is coming as how much? Check karo. It is milli, that means 10 to the power of minus 3. क्या आ रहा है 6.495 6.5 आंसर कितना आएगा बेटा चेक करो 12 sin 60 तो सब्स्टिट्यूट करो this is into 10 power minus 3 is there so this is 12 into 0.866 into 10 power minus 3 okay so I square is 25 into 25 and dm by d theta is 12 into 0.866 into 10 power minus 3 कितना आएगा आंसर 25 into 25 into 12 into 0.866 into 10 power minus 3 आ रहा है so it is coming around 6.495 6.495 आ रहा है clear yes चलो let us go for the next question a current 12 sin omega t 12 sin omega t plus 4 sin 3 omega t is passed through inductor as shown. The moving iron meter is kept. Then the reading of each instrument, if omega is 500 radi per second, this is electrostatic voltmeter, here electrostatic voltmeter, here moving iron. Try to answer this question. Electrostatic voltmeter and moving iron is kept. Try to answer this question. Answer please. See here, current is given as I of t is given as 12 sin omega t plus 4 sin 3 omega t. Okay, so what is IRMS? IRMS we can take it as 12 by root 2 whole square plus 4 by root 2 whole square. Okay, so how much we are going to get? This is 12 divided by root 2 square plus 4 divided by root 2 square. So this is coming as 8.944 amperes IRMS. And electrostatic voltmeter here, the voltage. Answer कितना आएगा? I into Z XL into 2. Approximately कितना आ रहा है? आंसर बताओ यार, कितना आ रहा है वोल्टमीटर का? See here, this we can take V is equal to I into XL. So this is I into omega L, J omega L. I into Z na voltage across this. Voltage across this. So I into Z. Z is how much? Z is equal to XL, J omega L. X is equal to omega X. Z is equal to XL. That is omega L. That is equal to 2 pi FL. So this is 2 into 3.14 into frequency कितना दिया है? Frequency दिया है. So okay, omega is directly given. Omega is given as 500. So this is 500 radian per second, and inductance is given as 2 millihenry, 2 into 10 power minus 3. So 1000, so it gets 1. Okay, so आंसर कितना आ रहा है? करंट तो आ गया, सिक्स 6.3 आएगा. So VRMS is equal to VM by root 2. So VM is coming as 8.944 into 1. 8.94 into 222. So V is this now. V is equal to I into Z. So I is equal to 8.94, 8.941. But this measures RMS value. VRMS means VM by root 2. So that is coming as 6.3 volts. So option B आ रहा है. That's not needed. Directly we can take V is equal to current. Current already आ गया ना. That's not required. 6.3 आएगा. Okay. Directly we can take I into Z. So इसका magnitude आपको मिला है ना. So current already we have taken IRMS because electrostatic voltmeter also takes that. 12 volts आ रहा है. 12 volts आ रहा है इसका आंसर. आंसर कितना आ रहा है इसका आंसर? एक बार चेक कर लो भैया कितना आ रहा है आंसर उसका. ऑप्शन ये आ रहा है. ओके 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 ऑप्शन ये आ रहा है. ओके चलो Answer this question. A moving iron ammeter shows full scale deflection of 120 degrees due to a torque of 300. Okay. Torque of 300 micronewton meter, which was produced by a current of 20 amperes. The rate of change of self-inductance of the instrument at full scale is dash. So what is given here? Torque is given, deflection torque is given as 300 micronewton meter. Okay, theta is given as 120 degrees. Okay, the current is given as 20 amperes. Okay, the rate of change of self-inductance is asking. So we know that TD is equal to, for moving iron, the formula is 1/2 I square dl by d theta. 1/2 I square dl by d theta. So this is mentioned as 300 into 10 power minus 6 and 1/2. Current is equal to how much? 20 amperes, 20 square. So you will get the dl by d theta. What is the answer? Please tell me for this. कितना आ रहा है आंसर इसका? ऑप्शन ये आ रहा है 1.5. ओके, 1. Okay, आंसर दिस क्वेश्चन ऑन एनर्जी मीटर. एनर्जी मीटर का क्वेश्चन जल्दी सॉल्व करो बेटा. Energy meter is designed to make 250 revolutions per kilowatt hour. Then the number of revolutions made by it when connected to a load carrying of 30 amperes at 250 volts and 0.8 power factor. Answer please. Energy meter is designed to make 250 revolutions, so n is equal to 250 revolutions. So he has given the k value. तो आपको पता है n is proportional to energy. If I remove the proportionality, I am going to get the energy meter constant k. I am going to get the energy meter constant k. So k is given there. So what is the k? K is given as 250 revolutions per kilowatt hour. Okay. Then the number of revolutions made by it when connected to a current. So first calculate the power. Power is equal to VI cos phi. So V is equal to how much? 250. Current is how much? 30. And power factor is 0.8. कितना होगा? तो simplify करके बताओ बेटा कितना होगा ये? 250 into 30 into 0.8. It is coming as 6,000 watts. Okay. So power is equal to energy is equal, power is equal to energy per time, energy is equal to power into time. So this is 6,000 watts. Time is given as 85 minutes. So this watt I am converting to hours, kilo, it will become kilowatts. So this will become kilowatt. So 1 hour is equal to 60 minutes. By 60, if you multiply, this will become a skill hour. Okay. So कितना आएगा? 6,000 into 85 divided by 6,000. It is coming as 8.5. E is equal to coming as 8.5 kilowatt hour. So he is asking the n. N is equal to k into E. So 250 into 8.5. How much you are getting? Any mistake we have done? Anywhere any mistake? V is equal to 250, I is equal to 30 amperes. आंसर कितना आ रहा है? पावर एट 8.55 किलोवाट आवर आ रहा है ना, टू 250 रिवोल्यूशंस 2125 आ रहे हैं मुझे. व्हाट इज द आंसर कमिंग फॉर दिस क्वेश्चन? एक बार चेक करो बेटा कितना मिस्टेक है हमारा. आंसर कितना आ रहा है? Yes, 2125 आ रहा है. So 2125 you are getting, right? That is the answer, right? Any mistake we have done? 250 revolutions per kilowatt hour into 8.5 kilowatt hour. That is correct only ना. Nowhere we have done mistake. 2125 आ रहा है मुझे. Answers given गलत है. Answers given. I think 2125 is the right answer ना. Yes. Okay, my dear. So are you satisfied by this session? So these are the various questions. Okay. Are you satisfied? Are you? I think you are for the BARC examination. Maybe sometimes more depthy calculations. 2125, yes, 2125 is the right answer. These answers are galat hai. 2125 is the right answer. Okay, so mostly the depth of the questions may not be that much because BARC exam is fundamentally conceptual. So almost measuring instruments I have discussed. Okay, so I wish you all the best for tomorrow's exam. Okay, I am closing the session here. If you have any other further doubts, you can ask me. If you have any other doubts, you can ask me, my dear. So tomorrow morning एग्जाम को फोड़ देंगे, अच्छी कॉन्सेप्चुअल क्वेश्चंस आएगा, सो डेफिनेटली आपको एग्जाम में बहुत अच्छा यूजफुल हो जाएगा. ओके, so I wish you all the best, my dear. If anybody is having any doubts, you can ask me here. Chalo, thank you.